Hello, everybody. This is the first lecture among the series of lectures that I mentioned in your classroom app. And with the help of these lectures, we will be covering the complete syllabus of your lifting machines. So there are quite a few number of lifting machines that are mentioned in your syllabus, and you have to remember, understand, and able to reproduce the derivations and the formulae of all these lifting machines. So first of all, to start with, I will just mention the names and just show you the figures of the lifting machines that we are going to study. The first one, as we have already studied or we have already come to know about, the most common, the most simple one is the lever. This is the image of a lever. So you apply the load at one point, and the point at which load is applied, that particular lever arm is the shorter arm. So it's shorter in length compared to the other lever arm, which is longer in length and where the effort is applied. And this is done in order to improve or increase what is known as the mechanical advantage. So lever is the first lifting machine. Then there is a simple pulley. You don't get any mechanical advantage out of this. They will come to know why. Then there is something called as system of pulleys. See, a simple pulley will never give you a mechanical advantage. And by the word giving mechanical advantage means the mechanical advantage should be greater than one in order for you to feel some comfort in lifting some load. For example, if I am lifting 100 newtons of weight and I have to apply 100 newtons of effort, then I will say that I am not getting any mechanical advantage. But in this case, what is the value of mechanical advantage? It's simply 1. And how does it become 1? You know that mechanical advantage is load lifted upon effort applied. And if the load and effort are both same, then mechanical advantage will come out to be equal to 1. So for any lifting machine, if your mechanical advantage is either 1 or even in some cases, if it is less than 1, then you will say that you are not getting any mechanical advantage. How does mechanical advantage get less than 1? It is that case in which, for example, if you are trying to lift a load of 100 Newton, and in order to do that, you actually have to apply an effort of 110 Newton. So you are expending more force to lift a lesser weight. And then the immediate question that comes to your mind is, then what is the use of that machine? Yes, we will discuss that also. The use of that machine is that it allows you to apply your effort in the downward direction, which is more comfortable or convenient for you. So although you are expending more force in comparison to the load that you are lifting. And how does that happen in the first place? It is because the hinges of the pulley or the, the rotary or the rubbing parts of the pulley that allow the rotation of the pulley itself, they have developed some rust or corrosion, and due to which it has got a lot of friction. So due to the presence of frictional forces in the moving parts of the pulley, the effort that you have to apply is larger than the weight you are lifting. So that is the practical case, and no matter which pulley you go and pick up all around the world, it will always have some small amount of friction, although no matter how well lubricated it is. So in every case, you keep it in mind, the actual effort that you will be applying on any pulley will always be greater than the weight that you are lifting. So it is not a very good lifting machine, okay, because its mechanical advantage is always less than 1. Okay, anyway, then why do we use pulleys? Anyway, why is engineering so much obsessed with pulleys? You are going to study a lot of pulleys, system of pulleys, and then you will learn belts and rope drives, which are again based on pulleys. So everywhere you see that in engineering you are dealing with pulleys. So if the pulley is something that always gives a mechanical advantage of less than one, the obsession with pulleys is that it at least allows you to apply your effort in a comfortable or convenient direction. Now just imagine pulling a weight out of a well, or let us say you are trying to collect some water in a bucket from a deep well. एक कुएं से पानी भरने की कोशिश कर रहे हो and you don't have a pulley. So what you will do is you will have to bend down, lower the bucket into the well, and you will have to physically lift the bucket itself with the help of a rope. And in that case you will be applying your effort in the upward direction while pulling the rope physically with the help of your hands. So any effort that is applied against gravity compared to the effort which is applied in the direction of gravity will always be inconvenient for you to apply. So the answer to the question that why are pulleys used in engineering although their mechanical advantage is less than one, the answer to this question is that they allow you to apply the effort in a convenient direction. That is all. Okay. But anyway, this is not the end of pulleys, because although a single pulley as shown in the figure will not allow you to achieve any mechanical advantage, but there are something called as systems of pulleys. So there is a first system of pulleys which is shown like this. We will come to the discussion of these pulleys a little while later. Then there is a second system of pulleys. This looks like this, and then there is a third system of pulleys. So by using a combination of pulleys in an intelligent way, we will look at the mathematics and all the details of this, you actually get to improve the mechanical advantage. So if you use a single pulley, you don't get a mechanical advantage. But if you use a combination of pulleys in an intelligent way, then you gain a lot of mechanical advantage. So we will be studying up to the third system of pulleys in this lecture. And then later on, we will cover simple wheel and axle, which looks like this. Then wheel and differential axle. This is it. We will study all the details. I will explain everything when we come to these particular objects. Then Weston's differential pulley is there. And then worm and worm wheel is there. Single purchase winch crab, double purchase winch crab, screw jack. It has got a long derivation and it is very difficult to work out on your own. Differential screw jack. So at least 13 number of lifting machines have to be studied by you, and you have to remember their formulae also. And even small numerical problems can be asked out of any of these lifting machines. So as you can see, this whole task is so enormous to study 13 different lifting machines and to remember their formulae. And just let me interrupt myself. I have made a summary of all the formulae and put it in one place also. This is actually given in the textbook by D.P. Sharma. This engineering mechanics by D.P. Sharma. I have made this whole set of notes for this particular lecture from Engineering Mechanics by D.P. Sharma. So you can go and refer to that book directly from the topic of this one, lifting machines. And even all the practice problems have been proposed by me from the same book. So the explanation of lifting machines in this book is very good, and that is why I have picked up all these things. Now, let us slowly take some lifting machines at a time and put them in one lecture. So I will be taking a few lectures, including some 3 or 4 lifting machines per lecture. So that if I try to explain all 13 lifting machines in one lecture, it will become very tiresome for you to look. And even it will become problematic for you to search for the part where I'm explaining a particular lifting machine. So anyway, in this lecture, we will be covering lever, simple pulley, first system of pulleys, second system of pulleys, and third system of pulleys. So this is what we will be doing in this lecture. Anyway, 1 second. Okay, we will start with levers. Now, as you can see, we have already understood levers to a certain extent in our previous lecture. So I will not waste much time on levers. It's a very simple topic. So on the shorter arm, it's basically lever is a straight or a one single rod which is attached with a fulcrum. This allows the rotation of the rod, and here you apply the weight or the load, and here you apply the effort. And these A and B are not the distances moved by the effort and weight. No, these are the lengths of the effort arm and the load arm. We will call this as the load arm and this as the effort arm. So A and B are not the distances moved by P and W. If you want to measure the distance moved by P and W, which if you remember in the previous lecture, they are mentioned as Y and X. Y is the distance moved by P and X is the distance moved by W. And then we define another term which is called as velocity ratio, and that is given by Y upon X. So Y and X are not mentioned in the figure at all. Please understand that. But in any case, in all the lifting machines, what we are going to do is that we are in some way or the other, we are going to develop the expression for velocity ratio. मतलब हम हर लिफ्टिंग मशीन के अंदर जाकर के डेरिवेशन किस चीज का कर रहे हैं, वेलोसिटी रेशियो को पता करने का डेरिवेशन कर रहे हैं. यही हमारा उद्देश्य है. And why are we so much concerned about the velocity ratio? Because in the previous lecture, I already explained to you that mechanical advantage is not constant for any machine. It is not constant for any machine. It changes with the change in load value. But on the other hand, velocity ratio for a given machine is constant. So the constant quantity of velocity ratio is a fixed entity for any given machine. So that is why for any machine setup, we are interested to know what is the velocity ratio of that machine. And with the help of velocity ratio, we can work out a lot of things that can be done with the help of that machine. So once again, हमारा उद्देश्य क्या है, हर लिफ्टिंग मशीन में अपन जाएंगे और उस मशीन की वेलोसिटी रेशियो का फॉर्मूला निकालने की कोशिश करेंगे. यही अपना उद्देश्य है. ओके, so now for a lever what we are doing is take moments of both the forces about the fulcrum point. Now before doing that, you have to assume that the P force applied at the effort end to lift the load W is in such a way so that this lever is exactly maintained in the horizontal position. But initially, how was this lever placed? This lever initially was like this. This is the fulcrum point, and the lever was like this. So the W load was lying on the ground here, attached to the load arm, and there was no effort applied to the lever arm. But now you introduced a force of P on the effort end, and this lever moved by rotating like this, and it came in this position. So in this position, an equilibrium is being considered. That is the first thing that you should know. So the equilibrium is like that, so that when the effort is applied here and the load is being lifted from here, then the arm of the lever is maintained in equilibrium in the horizontal position. So in this condition, we can say that since this whole system is held in equilibrium, so that means if I take the moment of all the forces about any point, then the sum of all the moments must come equal to 0. This is a condition of equilibrium if you remember from your very early classes of engineering mechanics while we started the session. The sum of moments for all forces will be zero. The sum of forces themselves in any particular direction, whether in vertical, it will be zero. The sum of forces in the horizontal direction will be zero. These are the conditions of equilibrium. But in our case, we will be making use of this one equation, and that would be sufficient for us. Because what is our aim? We are not going to find any other quantities. We are going to find only velocity ratio. So that can be easily achieved by using one single equation of equilibrium. So anyway, about the fulcrum, if I take the moment of this load W, then the moment will be equal to W multiplied by perpendicular distance B. So W into B is the moment about fulcrum of load W. And what is the direction of rotation of this moment? If you apply the rocket analogy that I taught you earlier, then this has a tendency to rotate in this direction, that is clockwise. So I will put a clockwise symbol for the moment of WB. Similarly, if you take the moment of load P about the fulcrum, then it is P multiplied by the perpendicular distance A. So P multiplied by A, again applying the rocket analogy, the direction of rotation about the fulcrum is like this. So this will be anti-clockwise. So I will put an anti-clockwise symbol here. Okay. Now, these are the only two moments that are possible about the fulcrum. So if you add them up, now please use the proper symbol or the proper sign for the moments also. Clockwise moment is negative, so I put a minus sign. Anti-clockwise moment is positive, so I put a positive sign. So according to this equation that the sum of moments of all forces must be equal to zero, what I get is minus WB plus P into A must be equal to 0. Or in other words, P into A is equal to W into B. Now what I will do is I will divide it here. W by P, I am rearranging this equation. W by P becomes equal to A by B. So for a lever, this ratio will always hold true. Now what is W by P? You already know that the ratio of load lifted to effort applied is called as mechanical advantage. So what we get is that the mechanical advantage of a lever can always be found as the ratio of the lever arm length to load arm length. So this is lever arm length, this is load arm length. And since the lever arm length is always taken larger compared to the load arm length, you can expect this ratio to be greater than 1. But again, you should remember that mechanical advantage is not constant. If you introduce friction at the fulcrum, then this balance will be disturbed. Then it is not exactly equal to A by B. Then some friction will also be involved and mechanical advantage will get reduced. But anyway, our aim was not to find mechanical advantage. Our aim was to find velocity ratio. But what do we do in this case? Now we take a simple assumption. Since we now know by all this discussion that mechanical advantage is equal to A by B when there is no friction. So in the absence of friction, MA is equal to A by B. Now what do you know about efficiency of a machine? Efficiency of a machine is mechanical advantage divided by velocity ratio. So now I will repeat my statement. Mechanical advantage is A by B when there is no friction. And when there is no friction, your efficiency is equal to 1. So that means when there is no friction, your mechanical advantage must be equal to velocity ratio. And due to this, we say that the velocity ratio of a lever is equal to A by B. So this is your first result. What is the velocity ratio of a lever? A lever has a velocity ratio of A by B, where A is the length of the lever arm and B is the length of the load arm. So velocity ratio is always greater than 1. Okay. Now, I ask you a tricky question here. What will happen if there is friction in the fulcrum? Will the velocity ratio change from A by B? The answer, surprisingly, is no. The velocity ratio will remain equal to A by B. What is going to change if friction comes here? This equation will change. Mechanical advantage will no longer be represented by A by B, but velocity ratio remains A by B if you introduce friction here. Okay, so this completes your simple lever. Now, just in order to understand the concept of a lever, you should also know that lever is not always a simple lever. There is something called as a bell crank lever also. Bell crank lever. ये क्या चीज होती है? This looks something like this. Now I am just drawing a simple construction of a bell crank lever. Okay. It generally takes the shape of an L alphabet from your English language. This is the fulcrum point. This central point is the fulcrum. So I will draw the fulcrum also. So this is the fulcrum. Now you apply the effort towards the back side, and this is where you suspend or lift the load. So what happens is this L-shaped structure is a solid lever. See, this is a solid lever. Now when you pull it backwards, the lever arm will rotate around the fulcrum, and this sort of rotation will be obtained at the effort end, and this sort of rotation will be obtained at the load end. You can see this point will come here. This is how your lever arm is going to look after rotation. So this is just for your general knowledge. There are even other types of levers which are possible, made in different shapes, but the overall concept is the same. At the longer end, you apply the effort. At the shorter end, you lift the load. Okay, so this I just included this for your information so that you don't remain limited with the knowledge that levers are always straight rods. No, levers can be constructed in many ways and many fashions, and apart from a straight lever rod, one of the most common and uh, commonly used levers is a bell crank lever. So this is called as a bell crank lever, which looks like a L-shaped alphabet of English language. Anyway, this being said, we will come to the next lifting machine, which is called as simple pulley. Now, for simple pulley, as we have already discussed, the concept is very simple. We are once again interested in finding the velocity ratio. Why? Because mechanical advantage cannot be chased after, because it will keep on changing with the introduction of friction as well as by changing the weight W. Mechanical advantage is never constant. You even looked at the graph of mechanical advantage versus load in your previous lecture, where mechanical advantage was taken at the y-axis and load was taken at the x-axis, and you saw that your curve is somewhat like this. It becomes a maximum at a value of 1 by m, where small m is the constant slope in the law of machines. What is law of machines? P is equal to mw plus C. So from the law of machines, M is the constant slope and the maximum value of mechanical advantage with respect to load that can be achieved for any machine is 1 upon M. So mechanical advantage, since it is not constant, we are not going to find any expression for mechanical advantage. It is useless to find a constant expression for mechanical advantage. All we are bothered about is somehow find the value of velocity ratio, because once you find that expression, this is a constant quantity, and no matter whether friction is introduced or friction is absent, whether load is changed, it is increased or decreased, it does not matter. The velocity ratio of a machine is fixed and will never change. And you can remember an expression for velocity ratio. So, what is the velocity ratio of a simple pulley? So, once again, let us imagine for starters that there is no friction here. It is perfectly smooth, and in this case, your P is equal to W. As you know, there is no long arm or short arm for a pulley. It has a constant radius of R. And since there is no long and short arm for a pulley, whatever load is there, at least that much effort you have to expend. If there is no friction, if there is friction, then P will be more. But anyway, we are considering that there is no friction. So P is equal to W. So immediately you can develop a temporary relation for mechanical advantage. And what is that? If P is equal to W for a machine for a given instant, then mechanical advantage is simply W by P. And if you rearrange this, bring P below W, then what you get is W by P equal to 1. So mechanical advantage is equal to 1 when there is no friction. And when there is no friction, efficiency is equal to 1. That means mechanical advantage upon velocity ratio is equal to 1. And from this, you say that when there is no friction, mechanical advantage is equal to velocity ratio. And since mechanical advantage in the absence of friction is 1, so that means velocity ratio is equal to 1. So we have obtained the expression for velocity ratio equal to 1 for a simple pulley. And now, if I pose the question, what will happen if the pulley has developed some friction at the joints? Will the velocity ratio change? No, it will not change. It will stick to the value of 1, but mechanical advantage of 1 will reduce further even from 1. So in the case of a friction induced pulley or a pulley which has some friction, the mechanical advantage will be, let us say, some 0.8 or zero point 0.9 something. So mechanical advantage will change if friction comes in. But once you know the expression of velocity ratio, it is going to stick. तो फ्रिक्शन हो चाहे नहीं हो, अब आपसे अगर कोई पूछे कि पुल्ली का वेलोसिटी रेशियो क्या है, 1 है साहब, फिक्स है वो, और आपसे कोई पूछे कि अगर फ्रिक्शन आ जाए तो वेलोसिटी रेशियो कितना होगा पुल्ली का, 1 ही रहेगा, मैकेनिकल एडवांटेज चेंज हो जाएगा, बस दैट्स इट. So with this, we have covered simple pulley and lever. So for lever, velocity ratio is A by B. Simple pulley velocity ratio is 1. You don't have to remember these expressions. ये तो टेम्पोररी एक्सप्रेशंस है. और अगर जनरली आपसे कोई पूछे कि मैकेनिकल एडवांटेज का कुछ एक्सप्रेशन तो बता दो लीवर के लिए, तो आप बोलना है कि चलो एक काम करो, आप ये बताओ कितना लोड लगा रहे हो, डब्ल्यू लगा रहा हूँ, एफर्ट कितना लगाना पड़ा, पी लगाना पड़ा. ये सब कोई मतलब नहीं है, फ्रिक्शन है नहीं है, शायद होगा फ्रिक्शन और फ्रिक्शन के साथ ही पी एफर्ट लग रहा होगा, बोलना यही है मैकेनिकल एडवांटेज. So the general expression for mechanical advantage for any machine is always load lifted upon effort. That's it. And this does not make much sense also. या फिर इसकी कोई कोई परिभाषा नहीं है. ये तो सिर्फ बेसिक डेफिनेशन है और वही आपके मैकेनिकल एडवांटेज की डेफिनेशन भी हो जाएगी, क्योंकि ये चेंज होती रहती है. This is not constant. So beyond stating that the mechanical advantage is W by P, you cannot expect much for mechanical advantage. But velocity ratio is fixed for a machine. So anyway, in this instant, we have covered lever and simple pulley. Now we move on to the first system of pulleys. Now this is where the pulleys start to give you an actual mechanical advantage, even if there is friction present. So let us see how a combination of pulleys can be intelligently used to extract some additional benefit. But before going to the expression of velocity ratio, we have to understand the construction of the first system of pulleys. See, there is a first system of pulleys, second system of pulleys, and third system of pulleys. But all you have to remember is what is a system of pulleys? It's a way of arranging pulleys and ropes. And in a way, when you pull the rope at one end, the load will get lifted. And you will feel, due to the combined effect of all these pulleys and due to the mathematics involved in this, the physics of this system behaves in such a way so as to reduce your effort in lifting a heavy load. तो इस तरह का अगर सिस्टम अगर आप कंस्ट्रक्ट करते हैं तो आपको कम एफर्ट लगाना पड़ेगा भारी लोड लगाने के लिए. Now let us understand the construction. Okay, see, this is a fixed ceiling. ये छत है मान लो. This pulley is fixed to the ceiling. ये जो स्टेम आ रहा है इस स्टेम से पुली को फिक्स कर रखा है, तो पुली रोटेट तो होगी लेकिन ये पुली कभी भी ऊपर और नीचे मूव नहीं कर पाएगी. सो दिस इज अ फिक्स्ड पुली. दिस इज अ फिक्स्ड पुली. Now what about the rest of these three pulleys? Have a look at these. The rope starts from here. It is wound around this fixed pulley. It comes down. It goes from the bottom of the second pulley and this rope is then attached to the ceiling. The rope is fixed. ये रस्सी यहीं खत्म हो गई. तो ये पहली रस्सी थी. But this pulley is neither fixed at the top nor fixed at the bottom. ये movable है. So just imagine what will happen if you pull this rope from here. इसको यहाँ से आप जैसे कुएं से पानी भरने के लिए खींचते हो. If you start pulling this rope downwards, what will happen? This rope will move upwards, and this whole pulley as well as the center line of this pulley will be forced to move upwards. तो ये मूवेबल पुली हो गई. देखो ये धागा यहाँ से फिक्स है तो ये पुली ऊपर को चलेगी. पुली का सेंटर ही ऊपर को मूव करना चालू कर देगा. Now, once having understood this concept, now look at the further arrangement. ये पुली तो मूवेबल हो गई, and from this stem another thread is started and taken from the bottom of the third pulley, and again this thread is attached to the ceiling. So now what will happen? If this pulley starts to move in the upward direction, then this thread will be pulled upwards. And when this thread is pulled upwards, since the end of this thread is attached to the ceiling and fixed, this third pulley will again be forced to move in the upward direction. तो ये third pulley भी movable pulley हो गई. ये fixed नहीं है. तो second pulley जब ऊपर चढ़ेगा, इस धागे को खींचेगा. इस धागे के खींचने से यहां से धागा जाएगा और चूंकि धागा यहां तक लेंथ लिमिटेड है तो फिर ये जो थर्ड पुली की जो सेंटर है ये मजबूर हो जाएगी ऊपर चलने को. सो थर्ड पुली विल आल्सो बी लिफ्टेड अपवर्ड्स एंड प्रोसीडिंग इन अ सिमिलर फैशन there is another thread which is attached to the fourth pulley like this, and again it is attached to the ceiling and fixed over here. तो जब फर्स्ट पुली के यहां से धागा खींचा गया तो सेकंड पुली ऊपर गई. सेकंड पुली के ऊपर जाने से थर्ड पुली ऊपर गई. थर्ड पुली के ऊपर जाने से फोर्थ पुली का सेंटर भी ऊपर जाएगा. एंड व्हेन द फोर्थ पुली सेंटर मूव्स अपवर्ड्स, please have a look where the load is attached. This load is attached to a stem which is connected to the center of the fourth pulley. So eventually when the center of the fourth pulley climbs up, this load will slowly start lifting upwards. But in all this combination, what you have to understand is, अगर मैं यहां से धागे को 10 मीटर खींच करके अपने पैरों पे इकट्ठा कर लूं, मैं यहां से खींचे जा रहा हूं तो धागा जो है क्या होगा, ये मेरे नीचे जमीन पे ऐसे ही इकट्ठा होता रहेगा खाली आकर के. So I just imagine that I have pulled down 10 meters of rope. Do you think that the load will also be lifted by 10 meters? No. तो अगर मैं 10 मीटर धागा खींचता हूं तो लोड कितने मीटर ऊपर गया? इस चीज का आंसर देता है वेलोसिटी रेशियो. व्हाट इज वेलोसिटी रेशियो? वेलोसिटी रेशियो इज द रेशियो ऑफ हाउ मच डिस्टेंस डिड द एफर्ट एंड ट्रेवल. तो अगर मैं अपने हाथ से एफर्ट लगा करके यहां पर देखो, यहां पर पी लगा हुआ है ना, यहां पर देखो, आई विल जस्ट सी पी इज हियर. So if I am applying my effort at this end of the rope, and by applying P effort I have pulled down 10 meters, then Y is 10. Now I want to know, by doing this, after the thread has traveled through all these pulleys and all these pulleys have climbed up, 2 has climbed up, and with the help of 2, 3 has also climbed up, with the help of 3, 4 has climbed up, and the distance climbed by 4 is the actual distance climbed by the load. तो ये 10 मीटर तो नहीं चलेगी, ये कुछ कम चलेगी. And let us say this traveled a distance of x. So we just want to find out what this x is. Okay. So once again we will apply some physics to this problem and understand the equations. Now you again see, you consider an instant when I have applied some force P and now I am not pulling it, I am just holding the thread. मैंने इस धागे को बस पकड़ के रख लिया है, ठीक है, छोड़ नहीं रहा हूं, ना खींच रहा हूं. And while holding this thread, what is happening is this load is resting in the air midway. हवा में इसको लटका के पकड़ रखा है मैंने. तो अब we are considering an equilibrium situation. So in equilibrium, the load W is acting downwards. और इसके immediate connections को देखो. So the load W is acting at this point also. This is also W. So downward force is W. And there are 2 threads that are attached to this pulley. This one and this one. So the tension in these 2 threads will be the same. This is in equilibrium. There is no motion. So both these threads will have tension T. So you simply apply this equation. Twice of tension in the upward direction and downward direction there is W. And both these upward and downward forces must cancel out each other. And that is the only condition in which this pulley, which is actually movable, is actually staying still in the equilibrium condition. तो आप सीधे सीधे 2T को अगर equal to W रखो, so each tension in the thread comes out to be W by 2. And that is what is shown over here. इस फिगर में ऑलरेडी इन्होंने बना करके जो दिया हुआ है, ये टेंशन की वैल्यू है. तो इस थ्रेड में टेंशन W by 2 है, इस थ्रेड में टेंशन W by 2 है. And now similarly apply the equation of equilibrium to this pulley. इस अकेले पुल्ली के ऊपर अब equation of equilibrium लगाओ. As you can see, since I am not moving the effort, the load is also not getting lifted, it is just hanging in the air. So this pulley is also not moving, this is also not moving, this is also not moving. ये तो मूव कर ही नहीं सकती, ये सिर्फ घूम सकती है, ये तो ऑलरेडी सीलिंग से फिक्स कर रखी है. So the movable pulleys are pulley number 2, pulley number 3 and pulley number 4. And none of the movable pulleys are moving right now because you are simply putting or suspending the system in equilibrium. बस पकड़ के रखा हुआ है. तो आप ये कह सकते हो कि ये जो P एफर्ट मैंने लगा रखा है उससे मैंने लोड को उठा तो लिया है. तो आपने मशीन से काम तो ले लिया है, लेकिन अभी इक्विलिब्रियम में पकड़ के रखा है. Now under the condition of equilibrium, again if we look at this pulley alone, since it is neither moving upwards and nor going downwards, so that means the sum of all the forces in the upward direction must be equal to the total force in the downward direction. अब देखो इस थ्रेड में कितनी टेंशन थी? The tension in this thread was W by 2. So that is the downward force. तो अगर पुली नंबर 3 को मैं अगर फ्री बॉडी डायग्राम बनाऊं, again there are 2 tension values on pulley number 3 and they have to be the same because they are one and the same thread, and the downward force that is pulling pulley number 3 downwards is W by 2. And since the upward forces are 2T and the downward forces, there is only one force which is W by 2. So in this case, for pulley number 3, the tension must be equal to W by 4. And that is shown over here. W by 4 is the tension on both the strings of pulley number 3. Now, just in this fashion, if you keep on applying this concept to the each adjacent next upper pulley, ये कॉन्सेप्ट इस पे लगाया, वही कॉन्सेप्ट इस अपर पुली पे लगाया, यही कॉन्सेप्ट अब इस अपर पुली पे लगाऊंगा, तो अगर मेरा यहाँ पे टेंशन W by 4 है तो इन दोनों का टेंशन W by 4 का हाफ होगा, दैट इज W by 8. Now look at this pulley. This pulley is not rotating. This effort is not moving downwards. This thread is also not moving. Now look at this. This thread is a continuation which is going like this. ये पूरी एक धागा है. तो इस पूरे एक धागे को अगर मैंने पकड़ के रखा है तो इस धागे में कहीं पर भी मैं एक जगह पे पूछूं कि कितना टेंशन है तो वो कांस्टेंट ही होगा. And since the tension at this point of this string is W by 8, so the simple conclusion that we draw is कि आपने कितने एफर्ट से इस लोड को पूरा पकड़ के रखा है, this has to be W by 8 only, क्योंकि ये पूरा एक धागा है. ये देखो, this is one string, so whatever value of tension is available at any one point of the string, that will be the value of your P with which you are holding it. So what is the eventual conclusion? The total load was W, that is being lifted or simply suspended in here, and the effort that you are applying to lift this load W is only 1/8 of the total load. तो अब देखो मिला कि नहीं मिला आपको मैकेनिकल एडवांटेज. नाउ व्हाट इज द वैल्यू ऑफ मैकेनिकल एडवांटेज? मैकेनिकल एडवांटेज इज लोड लिफ्टेड अपॉन effort applied, and in this case this is simply W is W, P is W by 8, so that is equal to 8. Now I will add a little bit more perspective. I get mechanical advantage equal to 8, which I can also write as 2 raised to power 3. Now what is the significance of writing this as 2 raised to power 3? आपके फर्स्ट सिस्टम ऑफ पुलीज में टोटल कितनी पुलीज हैं? 4 पुलीज हैं. 1 2 3 4. आपके टोटल सिस्टम ऑफ पुलीज में कितने मूवेबल पुली हैं? The number of movable pulleys out of these total 4 pulleys is only 3. 1 2 3. So the general formula for mechanical advantage for the first system of pulleys in the absence of friction, please mind it, ये पूरा अपन ने खेल absence of friction में ही किया है. This comes out to be 2 raised to power n, where n equal to number of movable pulleys. See, n number of movable pulleys अगर आपके first system of pulleys में होंगी, तो mechanical advantage in the absence of friction will be 2 raised to power n. And since we are considering absence of friction, that means efficiency, sorry this is n, efficiency equal to 1, क्योंकि friction आप नहीं ले रहे हो. So that means mechanical advantage is equal to velocity ratio. So the velocity ratio becomes equal to 2 raised to power n. So this is what you have to remember. So the eventual conclusion of your derivation is velocity ratio for the first system of pulleys is equal to 2 raised to power n, assuming 100% efficiency. लेकिन अगर मैं 100% efficiency नहीं लूं तो क्या अब velocity ratio change होगा क्या? नहीं. Velocity ratio will remain the same even if efficiency decreases, but mechanical advantage will no longer be represented by 2 raised to power n. In the case of loss of efficiency or in the case of introduction of friction inside the system, velocity ratio is going to remain as 2 raised to power n. but mechanical advantage expression will change. It's not equal to this. Okay, तो अब ये n का क्या सिग्निफिकेंस आ गया? This system of pulleys can be extended to any number of pulleys that can be added to this system. अभी यहाँ पर 4 पुलीज यूज किए हैं, अब आप 8 यूज कर लो, 10 यूज कर लो, 50 यूज कर लो, अगर आपके पास इतना बड़ा सेटअप है पुलीज को बनाने का। तो जितनी ज्यादा पुलीज यूज करते जाओगे वेलोसिटी रेशियो उतना ही बढ़ता जाएगा। इन अदर वर्ड्स द एफर्ट arm will have to pull a lot of rope to lift the load by a slight amount. ठीक है? So this is the conclusion of your first system of pulleys. Now let us come to the second system of pulleys. अब सेकेंड सिस्टम ऑफ पुलिस जैसा अपन ने फर्स्ट को पढ़ लिया है तो सेकेंड सिस्टम ऑफ पुलिस को कवर करना आसान होगा, बट अगेन लेट अस अंडरस्टैंड द कॉन्फ़िगरेशन फर्स्ट. See, this consists of the second system of pulleys consists of two sets of pulleys. ठीक है, यहां पर तो ये सारे पुलीज एक सेट है, लेकिन यहां पर दो डिफरेंट सेट्स ऑफ पुलीज हैं. लुक एट दिस कॉन्फ़िगरेशन. सीलिंग से एक प्लेट को पहले सस्पेंड किया गया, ये देखो ये थिन प्लेट है, एंड एट डिफरेंट लोकेशंस ऑफ दीज प्लेट्स यू अप्लाइड पिन जॉइंट्स, और उन जगहों पे पुलीज को अटैच किया गया. सो नाउ as you can understand from this configuration, this is the first set of pulleys. और ये फर्स्ट सेट ऑफ पुलीज एक रॉड से कनेक्टेड है, तो इसका मतलब है कि ये रॉड खुद सीलिंग से फिक्स कर दी और पुलीज को रॉड पे फिक्स कर दिया. तो ये पुल्ली अपनी अपनी जगह पर तो घूम सकते हैं, लेकिन आपस में रिलेटिव मोशन नहीं कर सकते. This is not allowed. These pulleys are non-movable pulleys now. So the first set of pulleys in the second system of pulleys is always ये तीनों pulleys non-movable हैं या फिर fixed pulleys हैं, non-movable pulleys. Now similarly look at the other set of pulleys. ये देखो अब उसके नीचे एक पूरा set of pulleys को आपने suspend कर दिया है. ठीक है, again see these three pulleys are also connected with the help of a straight rod. So although there cannot be relative motion among the pulleys, but this whole set of pulleys can climb up. ये तीनों एक साथ मिलकर के ऊपर को चल सकते हैं, या आप ये कह सकते हो कि ये जो रॉड दिख रही है ये रॉड खुद ऊपर को ट्रैवल या नीचे को ट्रैवल कर सकती है. तो इस रॉड के चलने के साथ ये तीनों पुलीज भी ऊपर नीचे ट्रैवल करेंगी. अब इसको कैसे बांधा हुआ है धागे से, ये देखो. इट इज all the pulleys are connected with one single thread. अब देखो कैसे किया है, धागा यहां से लिया, इस पुल्ली के ऊपर से लेते हुए गए, brought it all the way down to the last pulley, again wound it up, took to the second pulley of the first set, brought it down, took to the second pulley of the second set, brought it up, took to the third pulley of the first set, brought it down, wound it from the bottom part of the first pulley of the second set and then attached it here. यहां पर ला करके इस स्टेम से बांध. तो ये पूरा एक ही धागा है, इस तरीके से बांधा हुआ है, यो 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 और यो. This is all one single thread wound around two sets of pulleys. This is the configuration. Okay. तो अब एक चीज तो कह सकते हैं कि इस धागे पे कहीं पर भी अगर एक टेंशन की वैल्यू T है, तो ये टेंशन आपको इस धागे पे कहीं पर भी नाप लो वही मिलेगी. तो मैं पूछूं कि यहां पर कितना टेंशन है, T. यहां पे कितना टेंशन है, T. यहां पे कितना टेंशन है, T. यहां पे भी T, यहां पे भी T, यहां पे भी T, और इवन आपके हाथ से जो ये थ्रेड जा रही है इधर भी T टेंशन. So there is only one value of tension all throughout the thread because it is all wound in a spiral fashion around two sets of pulleys. So what is our mathematical conclusion from this? Now what we are going to do is इस सेकंड वाला जो सेट है, ये जो सेट है, इसी पे वेट लटका हुआ है। तो इसको एनालाइज करते हैं। यहां से एक कट मारा, ये एक्स एक्स सेक्शन दिखा आपको, यहां से अगर आप काट दो, so you will see that three threads are going up from the left side, three threads are going up from the right side. And if you consider the equilibrium of this complete set, वापस से आपने क्या किया, इसको थोड़ा सा खींचा जिससे कि ये वेट थोड़ा सा ऊपर को लिफ्ट हुआ है। अब ये कैसे लिफ्ट होगा, ये वाला कंप्लीट सेट तो कहीं मूव नहीं करेगा, लेकिन ये पूरा का पूरा सेट ऑफ पुलीज ऊपर को चलेगा। दिस होल सेट विल मूव अपवर्ड्स। ठीक है, तो यू हैव हेल्ड दिस इन सच अ वे कि ये वेट अपने जमीन से उठ करके थोड़ा हवा में लटका हुआ है अभी। एंड नाउ यू आर नीदर पुलिंग द रोप नॉर यू आर रिलीजिंग द रोप। तो हवा में अगर आपने पी एफर्ट लगा करके इस डब्ल्यू को उठा के पकड़ रखा है, तो बेसिकली आपने लिफ्टिंग तो करी ली। एंड नाउ वी हैव टू फाइंड अ फाइंड एन एक्सप्रेशन फॉर वेलोसिटी रेशियो। तो उसको कैसे करेंगे, वापस से इसमें अपन फिजिक्स लगाते हैं इक्विलिब्रियम की। 6 number of tension values यानी कि 6 T values are facing upwards and these are lifting a downward force of single W, and this system is in equilibrium. So I can simply say that 6 times the tension value is equal to the total load W. So the tension in the thread T is only 1/6 of the total weight getting lifted. अब चूंकि यहां पर P आपने उसी धागे को पकड़ रखा है, तो यहां पर जो टेंशन है धागे में वो T है, और आपने जो फोर्स लगा रखा है वो P है। एंड सिंस दिस पार्ट ऑफ द थ्रेड इज आल्सो इन इक्विलिब्रियम, इट इज नीदर मूविंग टू दैट डायरेक्शन नीदर मूविंग टू दिस डायरेक्शन, सो दैट मीन्स द एफर्ट अप्लाइड इज सिंपली इक्वल टू द टेंशन ऑफ द थ्रेड। तो इसका मतलब अब इस इक्वेशन को देख करके मैं ये कह सकता हूं कि एफर्ट अप्लाइड इज नथिंग बट इक्वल टू W/6। And now once again I will rearrange, W by P is equal to 6. But again I will intelligently find a general expression out of this. I will say that W by P is equal to 2 multiplied by N. And in this case N is equal to 3. तो अब ये N क्या है? N is the number of movable pulleys in the movable set. अब देखो आप इसको इस तरह से कंसिडर कर सकते हो, सिंस देयर विल बी ऑलवेज टू सेट्स ऑफ पुलीज, नंबर ऑफ सेट्स कितने होंगे सेकंड सिस्टम में? दो ही होंगे। ठीक है, लेकिन अगर आप ये देखें कि फर्स्ट सेट तो फिक्स्ड पुलीज का सेट है और सेकंड सेट मूवेबल पुलीज का सेट है, ये पूरा सेट ऊपर नीचे जा सकता है। ठीक है, अब आपको ये गिनना है कि मूवेबल पुलीज में कितने पुलीज हैं, यानी कि कितने इस सेट में कितने पुलीज हैं। इसमें 3 पुलीज दिख रही हैं, तो आपका जो मैकेनिकल एडवांटेज है उसका फॉर्मूला हो गया 2n, मैकेनिकल एडवांटेज दिस इज इक्वल टू 2n। एंड इफ देयर इज नो फ्रिक्शन यू कैन से दैट वेलोसिटी रेशियो इज आल्सो 2n। अब अपन को वेलोसिटी रेशियो का एक्सप्रेशन मिल गया। अब आप बोलोगे अब तो फ्रिक्शन डालो चाहे नहीं डालो, वेलोसिटी रेशियो तो 2n हो गई, लेकिन फ्रिक्शन आ गया तो मैकेनिकल एडवांटेज फिर 2n नहीं रहेगी, वो चेंज हो जाएगी। ठीक है, सो द expression for velocity ratio for the second system of pulleys is 2n, where n is the number of pulleys in the movable set. अब कुछ लोग इसको इस तरीके से भी लिख देते हैं कि फॉर द सेकेंड सिस्टम ऑफ पुलीज, आई विल जस्ट रब आउट ऑल दिस। कुछ लोग इसको कन्वीनियंस के लिए ये भी कह देते हैं कि भाई देखो एक लॉजिक है, आपके मूवेबल सेट ऑफ पुलीज में 3 पुल्ली हैं, तो आपके फिक्स्ड सेट ऑफ पुल्लीज में कितने पुल्ली होंगे? उसमें भी 3 ही होंगे, पक्की बात है। 3 से ज्यादा और 3 से कम हो ही नहीं सकते ना। क्यों? क्योंकि आप इस तरीके से वाइंडिंग कर रहे हो, तो ऊपर से गया तो इसके नीचे से जाएगा, फिर इसके ऊपर से गया तो एक नीचे से जाने के लिए चाहिए, फिर ऊपर से गया तो एक नीचे से जाने के लिए चाहिए। तो इसीलिए जितने सेट ऑफ पुलीज ऊपर होंगे उतने ही सेट ऑफ पुलीज नीचे भी चाहिए, इक्वल नंबर में। So it's a simple logic that whenever you construct a second system of pulleys, the number of pulleys in the fixed set and the number of pulleys in the movable set, they have to be equal. तो अब मैं फॉर्मूला इस तरीके से भी बना सकता हूं कि मैकेनिकल एडवांटेज, चलो मैकेनिकल एडवांटेज को तो छोड़ दो, आई विल डायरेक्टली से द वेलोसिटी रेशियो इज नॉट 2n बट सिंपली n। और अब n की परिभाषा चेंज हो गई, बस n क्या है, n इज सिंपली टोटल नंबर ऑफ पुलीज, दैट्स इट। So you have to be careful while writing down the expression for velocity ratio। तो सेकेंड सिस्टम ऑफ पुलीज की दो तरह से लोग परिभाषा लिखते हैं वेलोसिटी रेशियो की। The first definition for velocity ratio they give for the second system of pulleys is that velocity ratio equal to 2n. But in this definition, n is the number of pulleys in the movable set only, which is equal to 3 in this case। और जनरल केस में तो आप इसको बढ़ाते भी जा सकते हो कि दोनों सेट्स में एक एक पुल्ली बढ़ा दो, तो इसमें भी 4 हो जाएंगे, इसमें भी 4 हो जाएंगे। दोनों सेट्स में एक एक पुल्ली कम कर दो, तो इसमें 2 हो जाएंगे, इसमें भी 2 हो जाएंगे। सो यू कैन कंस्ट्रक्ट any type or any second system of pulleys with any number of pulleys on attached to each set। तो ये तो एक केस लिया है अपन ने जिसमें 3-3 पुल्ली थे। अब 4-4 पुल्ली, 5-5 पुल्ली, 10-10 पुल्ली, कितनी जगह आपके पास अवेलेबल है, उस हिसाब से बड़ा सिस्टम भी बना सकते हो। सो दिस इज अ जनरल एक्सप्रेशन कि अगर मैं n नंबर ऑफ पुल्लीज से एक सेट बनाऊं तो वेलोसिटी रेशियो 2n हो जाएगा। और एक दूसरा मेथड क्या है वेलोसिटी रेशियो का, इसी के लिए वेलोसिटी रेशियो इज सिंपली रिटन एज n। और इस केस में n क्या चीज है, n इज द नंबर ऑफ ऑल पुलीज इन द सिस्टम। तो इस केस में क्या हो गया, स्मॉल n, 1 2 3 4 5 6। सो व्हेन you attempt or derive this expression in the examination, you have to specifically mention it like this: if n is the number of movable pulleys, then velocity ratio is 2n. On the other hand, if n is considered to be the total number of all pulleys, movable as well as non-movable, then velocity ratio is simply given by n। तो आप इन दोनों में से कोई एक डेफिनेशन को अडॉप्ट कर लो और उसको याद कर लो, दोनों एक साथ लिखने की जरूरत नहीं है। व्हेन यू राइट इट इन द एग्जाम, यू एक्सप्लेन कि n को क्या ले रहे हो, ये बता करके फिर अपना फॉर्मूला लिख दो, इनमें से कोई सा भी एक, ठीक है। सो दिस ब्रिंग्स अस टू द कंक्लूजन ऑफ द सेकंड सिस्टम ऑफ पुलीज, एंड नाउ लेट अस क्विकली कवर द थर्ड सिस्टम ऑफ पुलीज। दिस इज द थर्ड सिस्टम ऑफ पुलीज। Now, since you have already covered the first and the second systems, so the third system should not be very difficult to understand. Just a look at the figure will give you the idea of what is implied here. एक बार वैसे समझा देता हूँ. Again, when you look at the figure, this pulley is a fixed pulley. ये non movable है, ये सिर्फ rotate करेगी, ऊपर नीचे नहीं चढ़ेगी. But this one and this one are movable pulleys. ये ऊपर नीचे travel कर सकती है. Now see, there is a movable platform which is constructed. You take a thread, wind it from the top of one pulley, attach it to the platform. You attach a thread to the pulley's center, take it from the top of the second pulley and again attach it to the platform. Now you take another thread, attach it to the second pulley's center, take it from the top of the third pulley and again attach it to the platform. And similarly, you take another thread and bring it and attach to the platform. So this is how you have attached these pulleys. तो इसमें total threads कितने हो गए? क्या ये एक thread है या multiple threads है? As you can clearly see, there is one thread here, second thread here, third thread here, fourth thread here. तो चूंकि चार अलग अलग threads हैं तो चार tension भी आएगी. All tension values will be different. Now let us see how this works out. Okay? Once again, the working of the system will be like this. When I start pulling the thread from this end, what will happen is this platform will be pulled up from this thread. तो ये प्लेटफॉर्म थोड़ा सा ऊपर चढ़ेगा, एंड व्हेन द प्लेटफॉर्म क्लाइम्स अप ऑल दीज थ्री थ्रेड्स विल बिकम लूज, ये ढीली हो जाएंगी क्योंकि प्लेटफॉर्म ऊपर चढ़ गया है, यहां से खींच लिया आपने इसको, ठीक है. एंड व्हेन दिस थ्रेड गेट्स लूज्ड, this thread will travel over this and will be released to this pulley. ठीक है, तो ये पुली नीचे आएगा, आप फिर भी इसको खींचे जा रहे हो तो प्लेटफॉर्म ऊपर चढ़ेगा, उसी तरीके से ये पुली, ये धागा ढीला हुआ तो ये यहां से थ्रेड रिलीज करेगा और ये पुली नीचे आएगी, ये पुली भी नीचे आ रही है, ये धागा भी छोड़ रही है, तो ये पुली नीचे को आता ही चला जाएगा, उसी तरीके से ये पुली भी नीचे को आता चला जाएगा, ये पुली भी नीचे को आता चला जाएगा, एंड विद दिस द कंबाइंड एफर्ट and the combined effect will be that the platform will be slowly raised up while these three pulleys will be slowly moving down. I hope this is understood and it is clear to you. थोड़ा सा आपको इमेजिनेशन लगाना पड़ेगा क्योंकि इसका मेरे को कोई वीडियो नहीं मिला. I could not find a suitable video for this. Otherwise, I could have explained it in a much better fashion. So you have to apply a little bit of imagination. You pull it down, this thread will be lifted, so the platform will rise a little. When it rises a little, this thread and this thread will become slightly loose. इनके लूज होते ही क्या होगा, ये धागे यहाँ से खिंच जाएंगे, इधर को आएंगे, यहाँ से खिंच के इधर को आएगा और यहाँ से खिंच के इधर को आएगा. तो उस चक्कर में होगा क्या, ये लूज धागे जब इधर को रिलीज हो रहे हैं और आपकी ये जो पुलीज हैं ये अपनी रिलेटिव पोजीशंस चेंज करेंगी और उसके चेंज होने के साथ साथ ये प्लेटफॉर्म धीरे धीरे ऊपर को चढ़ता चला जाएगा. दिस इज द नेट रिजल्ट. ठीक है, नाउ वंस अगेन वी आर इंटरेस्टेड कि इस तरह के अरेंजमेंट का वेलोसिटी रेशियो क्या होता है. वी आर इंटरेस्टेड टू फाइंड दिस आउट. ठीक है, so let us find out what is this. The first thing is, once again you pull the rope a little and when the weight is slightly lifted above the ground, जमीन से थोड़ा सा ऊपर ये उठ जाए तो इसको पकड़ के रख लो. Now you are holding it. So you are holding this thread by applying an effort of P and the weight is simply hanging in midair. So that means you can say that by the application of my effort, I have successfully lifted the load W. ठीक है, तो अब इस इक्विलिब्रियम की कंडीशन में पहला धागा ले रहा हूं मैं, ये पहला धागा सिर्फ इधर से इधर तक है. एंड इफ आई एज्यूम दैट द टेंशन इन दिस थ्रेड इज T1, तो सीधी सी बात है, चूंकि ये धागा ना तो इधर जा रहा है ना उधर जा रहा है, इक्विलिब्रियम है, तो P बिकम्स इक्वल टू T1. ठीक है, ये तो फिक्स हो गई. एंड नाउ लुक एट द इक्विलिब्रियम ऑफ द पुली इटसेल्फ. द एफर्ट यू आर अप्लाइंग इज इक्वल टू T1, ये तो पता लग गया. अब देखो, अब ये भी T1 है बिकॉज P इज T1, ये भी T1 है. So both these downward forces are T1 and this pulley is neither moving upwards nor moving downwards. ना ये ऊपर चढ़ रही है ना नीचे आ रही है. तो इसका मतलब है इस पुल्ली को पकड़ के रखने वाला जो धागा है इसमें कितनी टेंशन होगी. दिस टेंशन मस्ट बी इक्वल टू 2T1 क्योंकि ये पुल्ली इक्विलिब्रियम में है. अब ये धागा देखो, ये धागा पूरा घूम करके यहां आ रहा है और इसमें टेंशन आप T2 मान रहे हो. So I can simply say that T2 is 2T1. अब यही लॉजिक मैं अगर इस पुली पे लगाऊं तो मेरे को मिलेगा T3 is equal to 2T2. And similarly, if I apply this on this pulley and this thread, then I get T4 is equal to 2T3. Now you start substituting this P in place of T1. तो अगर मैं T1 की जगह पर P रखूं तो ये कितना आ गया 2P. नाउ T2 इज इक्वल टू 2P. अब T2 की जगह पे अगर मैं 2P रखता हूं तो ये क्या आ गया 4P. अब अगर T3 की जगह पर मैं 4P रखता हूं तो ये क्या आ गया, 8P. So eventually I have something like this: T1 equal to single P, T2 equal to 2P, T3 equal to 4P, and T4 equal to 8P. And now look at this figure once again. अब इसमें से ये सारे फिगर्स में से ड्राइंग हटा देता हूं मैं, एंड लेट अस लुक एट द फिगर अगेन. See, the load is acting downward on the platform. Look at the equilibrium of the platform now. The load is acting downwards, W. T4, T3, T2 and T1 are combining themselves to lift this load W. तो इस प्लेटफॉर्म की इक्विलिब्रियम से मैं ये कह सकता हूं कि W is equal to T1 plus T2 plus T3 plus T4. I can say this by looking at the equilibrium of the platform. Now, for the sake of my writing simplicity, let me take to the other screen. अब यहां से मैं कंटिन्यू कर रहा हूं, यहां तक तो अपन आ गए थे that W is equal to T1 plus T2 plus T3 plus T4. Now we substitute the values of these tensions from our figure. T1 is P, T2 is 2P, T3 is 4P, T4 is 8P. इसको सब्स्टिट्यूट कर देता हूं यहां पर ला करके. So W is equal to P plus 2P plus 4P plus 8P. Now if you look at this series P, 2P, 4P, 8P, this is a geometric progression. I hope you remember what a geometric progression, arithmetic progression is. Geometric progression, or in short what you call it as GP, is a progression which goes like this: A, AR, AR square, AR cube, and so on. This is called as a geometric progression, where A is called as the first term, R is called as the common ratio, and then again in your early mathematics classes in your school days, you learned the sum of a geometric progression is given by a standard formula. So again, we have to recall that formula. What is this? The sum of the geometric progression, sum of n terms. भाई सम आप कहाँ तक करोगे? जैसे आपको एक ज्योमेट्रिक प्रोग्रेशन तो चलती जाएगी, इसमें आर 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 मल्टीप्लाई करते रहो, यू कैन इवेंचुअली अचीव इनफाइनाइट टर्म्स ऑफ अ ज्योमेट्रिक प्रोग्रेशन. तो अपन को अगर n टर्म्स तक की, दिस इज द फर्स्ट टर्म, द सेकेंड टर्म, द थर्ड टर्म, द फोर्थ टर्म एंड सो ऑन. So if you have to take the sum of n terms of a geometric progression, then you simply put it like this: a multiplied by r raised to power n minus 1 upon r minus 1. ये फॉर्मूला आपको याद रखना है. So let me bring it to the center stage. The sum of n terms of a geometric progression is given by the expression a r raised to power n minus 1 upon r minus 1. This is the sum of n terms. So let us look at the geometric progression which we have in our hands. The sum of terms that we have is, or let me write it completely, your expression is for w. Okay. So this is capital W was given as P plus 2P plus 4p plus 8p. So let us see how many terms we have. 1, 2, 3, 4. Since I have 4 terms, my n or small n is equal to 4. What is the first term of my geometric progression? It is p. So in this, a is equal to capital P. And now what is the common ratio that is being multiplied across each term? Multiplication of 2, again multiplication of 2, again multiplication of 2. So my common ratio for this geometric progression is 2. Now I have all the quantities I need to substitute in the general formula of sum of n terms. So if I put it here, A is P. So the sum of 4 terms is equal to W, because W is sitting on the left hand side, and this is the sum of 4 terms. So W is equal to A is P multiplied by common ratio raised to power n. Common ratio is 2 and n is 4 minus 1 divided by r minus 1. R is 2 minus 1. Now if I simplify it, this becomes P multiplied by 2 raised to power 4 is 16 minus 1 divided by 2 minus 1 is 1. So eventually what I have in my hands is W is equal to 15P. Now I have everything that I need to construct my velocity ratio. I will simply say W by P is equal to 15. What is W by P? This is mechanical advantage. And if I assume friction to be 0, then I can say that efficiency is 1, and in that case mechanical advantage upon velocity ratio, which is efficiency, is 1, which again indicates that mechanical advantage can be taken equal to velocity ratio when there is no friction. So my mechanical advantage is 15, so my velocity ratio is also 15. So what is my eventual formula out of this? How do I put it in a general formula? I will make use of this concept. Now you remember this. If there are a total number of n pulleys, see, in this case, the concept of movable and non-movable pulleys is removed. So you have to remember that for third system of pulleys, there is no concept of movable and non-movable. You simply have to count all the number of pulleys. तो इस सिस्टम में कितनी पुलिस दिख रही हैं? अब ये याद रखना, आप नंबर ऑफ पुलिस को बढ़ा भी सकते हो, कम भी कर सकते हो. You can remove these two pulleys, so the third system of pulley will contain only two pulleys. तो आपका मैकेनिकल एडवांटेज थोड़ा कम हो जाएगा. कोई दिक्कत नहीं है, आप पुलिस को बढ़ा सकते हो, कम कर सकते हो. इट इज जस्ट अ केस ऑफ थर्ड सिस्टम ऑफ पुलिस, जिसमें कि अपन ने 4 पुलिस ले रखी है. ठीक है. सो इफ द टोटल नंबर ऑफ पुलिस इज स्मॉल n, then your formula for velocity ratio is simply 2 raised to power n minus 1. This is the formula that we have derived. ये देखो आप, ये 15 जो वेलोसिटी रेशियो आई थी आपकी, कैसे आई थी? हाउ डिड यू गेट द वेलोसिटी रेशियो ऑफ 15? कैन आई राइट दिस एज 16 minus 1, and can I write this as 2 raised to power 4 minus 1? Yes, absolutely. And what is this 4? This 4 is nothing but the number of, or the total number of pulleys. 1, 2, 3 and 4, irrespective of the fact whether these pulleys are movable or non movable. बस आप तो total pulleys count करोगे third system of pulleys. So these are the formulae. And if we go to the extreme end of this chapter that I have given, you can remember these. First system of pulleys, velocity ratio 2 raised to power n. And what is small n here? Let us go and recall. फर्स्ट सिस्टम ऑफ पुलिस में मूवेबल और नॉन मूवेबल का कॉन्सेप्ट है कि नहीं है, ये अलग से याद रखना पड़ेगा आपको. फर्स्ट सिस्टम ऑफ पुलिस, व्हाट इज स्मॉल एन? n is the number of movable pulleys. So you have to remember it like that. ठीक है? सेकेंड सिस्टम ऑफ पुलीज में आपके लिए अगर मूवेबल पुलिस की बात करते हो तो वेलोसिटी रेशियो 2n है, और अगर सारे पुलिस एक साथ कंसिडर करते हो तो वेलोसिटी रेशियो n है। आप इन दोनों में से कोई एक ही याद रखें, दोनों एक साथ नहीं याद रखें। वैसे दोनों पता होने चाहिए, लेकिन एग्जाम में लिखते टाइम कोई एक लिखें। और थर्ड सिस्टम ऑफ पुलिस में जब आते हैं तो अगेन उसमें मूवेबल पुलिस का कॉन्सेप्ट नहीं है, तो टोटल नंबर ऑफ पुलिस हैं। सो नाउ यू गो बैक एंड रिमेंबर, इनको रट लो अब इन फॉर्मूलेस को। डेरिवेशन तो पता लग ही गया, ठीक है? सो इन दिस सिचुएशन n is number of movable, in this situation all pulleys, in this situation all pulleys, ठीक है? फर्स्ट सिस्टम 2 रेज टू पावर n है वेलोसिटी रेशियो, और जिसमें n सिर्फ मूवेबल पुलिस की काउंटिंग है। सेकेंड सिस्टम ऑफ पुलिस में n लिख लो वेलोसिटी रेशियो को, जिसमें n क्या है? ऑल द नंबर ऑफ पुलिस, वेदर मूवेबल और नॉन मूवेबल। थर्ड सिस्टम ऑफ पुलिस में वेलोसिटी रेशियो 2 रेज टू पावर n माइनस 1, जिसमें n क्या है? द काउंट ऑफ ऑल द पुलिस, वेदर मूवेबल और नॉन मूवेबल। तो दिस brings us to the conclusion of the types of pulleys, ठीक है? एंड नाउ टू कंक्लूड दिस, आपके जो एक न्यूमेरिकल प्रॉब्लम और ले ली है मैंने। देयर आर 4 पुलीज इन अ थर्ड सिस्टम ऑफ पुलीज, ठीक है? लेट अस डू दिस प्रॉब्लम ऑल्सो। कौन सा सिस्टम ऑफ पुलीज है? थर्ड सिस्टम ऑफ पुलीज है। फटाक से वेलोसिटी रेशियो लिख ली, क्योंकि रटा हुआ है। वेलोसिटी रेशियो ऑफ द थर्ड सिस्टम ऑफ पुलीज इज 2 रेज टू पावर n माइनस 1। एन एफर्ट ऑफ 150 न्यूटन इज रिक्वायर्ड। चलो एफर्ट दे रखा है तो P को भी नोट कर लो। एफर्ट P इज इक्वल टू 150 न्यूटन। So 150 Newton of effort is required to lift an unknown weight. वेट नहीं पता, यानी कि लोड नहीं पता कितना लिफ्ट हो रहा है। If the efficiency of this machine is 75%, efficiency is given as 75%, तो अगर मैं फ्रैक्शन के टर्म्स में लिखूं तो I will write it as 0.75. 75% is equivalent to 0.75. 100% is equivalent to 1. फाइंड द वेट लिफ्टेड। W पता करना है, एफिशिएंसी दे रखी है, एफर्ट दे रखा है, और वेलोसिटी रेशियो का फॉर्मूला अपन को रटा हुआ है। और क्या दिया हुआ है? देयर आर 4 पुलीज इन द थर्ड सिस्टम। तो ये स्मॉल n कितना हो गया? ये हो गया 4, ठीक है? ये बहुत ही सिंपल प्रॉब्लम है। तो वेलोसिटी रेशियो की वैल्यू कितनी हो गई? इट्स इजी। वेलोसिटी रेशियो इज इक्वल टू 2 टू पावर 4 माइनस 1 इक्वल टू 15, ठीक है? तो वेलोसिटी रेशियो 15 हो गई। नाउ एफिशिएंसी इज गिवन एज 0.75, तो मैं ये सीधे सीधे लिख सकता हूं, एफिशिएंसी इज मैकेनिकल एडवांटेज अपॉन वेलोसिटी रेशियो, दिस इज गिवन एज 0.75। I already know the value of velocity ratio, so I can say that this 0.75 is mechanical advantage upon 15, because my velocity ratio is 15. So I get the value of mechanical advantage. इस तरह की प्रॉब्लम आती है आपकी लिफ्टिंग मशीन से, बहुत सिंपल प्रॉब्लम्स आती है। The only thing that you need to do is practice and remember the correct formulae wherever they are applicable. So this is simply 15 multiplied by 0.75. अब मैकेनिकल एडवांटेज मिल गई। व्हाट इज मैकेनिकल एडवांटेज? मैकेनिकल एडवांटेज इज आल्सो इक्वल टू लोड लिफ्टेड अपॉन द एफर्ट, और मैकेनिकल एडवांटेज आपको पता लग गया 15 इंटू 0.75 है। Now you simply multiply the given value of P विद दिस क्वांटिटी, W मिल जाएगा। W इज इक्वल टू P कितना दिया हुआ है, 150 न्यूटन्स दिया हुआ है। सो W विल बी सिंपली 150 मल्टीप्लाइड बाय 15 मल्टीप्लाइड बाय 0.75। बस आपने सारे सिस्टम ऑफ पुलीज की डेरिवेशन सीख ली, आपने सारे सिस्टम ऑफ पुलीज में से एक प्रॉब्लम भी सॉल्व कर ली, जिस टाइप की प्रॉब्लम कैसे आती है, यू हैव कंसिडर्ड दिस आल्सो। ठीक है, दिस इज योर आंसर, यू कैन सॉल्व इट एंड फाइंड द आंसर। तो वी विल कंक्लूड दिस पर्टिकुलर लेक्चर हियर। तो जैसा कि मैंने आपको बताया था, मैं 2 मिनट और आपके लूंगा, जस्ट इन ऑर्डर टू मोटिवेट यू अ लिटिल। ये टॉपिक्स जितने मैकेन आपके इंजीनियरिंग मैकेनिक्स में हैं, दीज आर ऑल वेरी लेंथी टॉपिक्स। और अगर मैं इसमें ये भी इंक्लूड कर दूं कि हर टॉपिक से कितनी वैरायटी ऑफ प्रॉब्लम्स एग्जामिनर बना सकता है, तो ये एक बहुत ट्रेमेंडस टास्क हो जाता है। आपके पढ़ने के लिए ही नहीं, सिर्फ पढ़ाने वाले के लिए भी एक बहुत ट्रेमेंडस टास्क हो सकता है कि कितना ग्राउंड कवर किया जा सकता है। और हो सकता है कि आप लोगों में से कुछ लोगों को ये फ्रस्ट्रेटिंग लगे कि भाई आप 3 लेक्चर तो हफ्ते के लेते ही हो, फिर उसके बाद घंटे 2-2 घंटे की रिकॉर्डिंग और करके भेजते हो, हम ये देखें कब, हमारे पास डेटा नहीं है। द ओनली आंसर दैट आई कैन गिव टू सच पीपल, और if to such people whose mind develops such queries, is that अब इस सिचुएशन में आपके साथ में और कोई उपाय है ही नहीं। मैं चाहूं तो आपको ये सब सेल्फ स्टडी करके भी दे सकता था, क्योंकि अगर आप मेरे नोट्स देखें, आई विल बी वेरी फ्रैंक विथ यू, आई विल नेवर ट्राई टू फूल एनीबडी। इसमें मैंने अपनी तरफ से बहुत कम चीजें डाल रखी। ये देखो, ये पार्ट मैंने अपना टाइप किया है, बाकी ये जितने भी ये जो पार्ट्स दिख रहे हैं, दीज हैव बीन डायरेक्टली टेकन फ्रॉम द टेक्स्ट बुक। तो टेक्स्ट बुक में तो सब दे रखा है, और वही मैं आपको नोट्स बना करके सप्लाई कर रहा हूं। तो अगर मैं ये एडिशनल लेक्चर्स ना बनाऊं, तो फिर कुल मिलाकर के सहारा तो आपका टेक्स्ट बुक ही रह गया ना। और इनसे अगर आपको ये चीजें पूरी ऑटोमेटिकली समझ में आ जानी होती, तो फिर टीचर्स की जरूरत ही नहीं पड़ती। और सबसे पहली बात, काफी टाइम पहले इंजीनियरिंग डिसिप्लिन जो है, इट यूज टू बी अ वेरी वेरी टफ डिसिप्लिन, जिसमें कि लोग बहुत पढ़ाई करते थे। अब आज की तारीख में क्या हो गया है, सिलेबस श्रिंक हो गई है, आपका सेमेस्टर श्रिंक हो गया है, तो उसके चलते मोस्ट ऑफ द स्टूडेंट्स have started taking engineering to be a very very easy going profession। लेकिन ना तो ये पहले था और ना आज की तारीख में है। बस आजकल के स्टूडेंट्स इसको बहुत लाइटली लेते हैं, बस इतनी सी बात है। सो ऑल यू हैव टू डू इज यू हैव टू कम टू द सीरियसनेस कि ये जो 4 साल हैं, ये मस्ती कम करने का टाइम है और मेहनत ज्यादा करना है, क्योंकि फ्यूचर ब्लीक हो जाएगा अदरवाइज आपका। इफ यू लूज योर मार्क्स, your overall score in engineering, if it goes down, that becomes a permanent mark on you in the future that is to come। तो इसलिए आप लोगों को अगर एडिशनल लेक्चर्स मिल रहे हैं, ज़्यादा टाइम डिवोट करना पड़ रहा है, ये कड़वा घूंट मान करके आप अभी फॉर द टाइम बीइंग इसको पीजिए। मन नहीं लग रहा है पढ़ने में, तो भी आप मन लगाइए। टेक अ कप ऑफ कॉफी, टेक अ स्ट्रोल आउटसाइड, थोड़ी सी फ्रेश एयर खा के आ जाओ, थोड़ा सा योगा वगैरह करो, इफ इवन इफ इट इज पॉसिबल। बहुत अच्छी बात है, आपको लगेगा कि ये कुछ ज्यादा ज्ञान हो रहा है, बट इट्स अ वेरी इंपॉर्टेंट थिंग। थोड़ा सा योगा वगैरह करोगे, आपको सचमुच में मोटिवेशन मिलेगा। बट दिस इज द टाइम फॉर सैक्रिफाइस एंड सिटिंग डाउन टू स्टडी। तो अब आपको ऐसे भारी भारी लेक्चर मैं अपने घर से बना बना के भेज रहा हूँ, थोड़ा सा हैवी हो रहा है, आई नो दैट, but in order to cover your syllabus completely, and my purpose is to give you lectures on each topic। मैं भगा करके कुछ भी खत्म नहीं करना चाहता, लेकिन हफ्ते के 3 लेक्चर आपके मैकेनिक्स के सिलेबस को कवर करने के लिए बहुत कम है, and that is the reason why I am supplying you with these lectures। So please don't feel bad, and please be prepared for a little bit of sacrifice of your time and efforts while you are doing your engineering। engineering करके जब नौकरी लग जाएगी, then you are a free bird। there is a lot of time in future to enjoy, but that enjoyment should not come at the sacrifice of the time when you are supposed to study। so please be serious, and please try to understand why am I giving you such additional lectures। okay, so with that I hope that you will be motivated, and I will stop this lecture here।